Thank you for coming, everyone. We'll get all the echoes taken care of. And welcome to what every teacher needs to know about generative AI. All right, so we're going to talk today about generative AI in the classroom. As all of you have lived through since 2023, there has just been a lot of change in terms of how people are using AI, what they're using AI for, and just generally how much they're using it and how they really might be. They probably everybody's using it for most everything. But I want to start with this story of me in undergrad. I signed up for calculus with computer applications instead of regular calculus. And I thought that I was doing this to get out of the more difficult class. And it turns out that it was just a different way of thinking about it. So instead of learning how to do derivations by hand, which I still don't know how to do very well, they instead taught you how to put it into your calculator and do derivations in your calculator. And to this day, if I needed to derive something, I use Python or I use R. I do not do it by hand, right? But the whole mantra was right at the beginning, here's the tool, show your work. So you and this tool are collaborating together and help me understand what it is that you did and what the tool did. So we're going to go through 3 acts today. One is the bend, which gives us a context in time for where we're at. 2 is what I call the creature, which we're going to talk about how the LLMs generally work. So you have a general idea of how they operate and how people might be using them. And the third one is the compass, which is how we can guide people through using this stuff in an effective way. So first, the bend, what does that mean? Well, to go back to another story of CU, my freshman year, they had this closed circuit television in the dorms. And so you could sit there and watch classes instead of going to the classes that you're supposed to go to. And I repeatedly watched this talk by one of the physics professors about the power of the exponential function. And he kept railing about how the greatest shortcoming of the human race is our inability to understand the exponential function. I think we would all agree that the human race has more shortcomings than that, but it's one of the big ones. And why is it a big deal? Well, it leads to bad future projections. So generally, especially exponentials start out really flat. And when they're going flat, we tend to think that they're going to stay flat. And we extrapolate out in this straight line from the flatness. And then we are caught wildly by surprise when the thing takes off really quickly. And so this has happened with computers generally. So here we are back in 1904 with the very first computer being invented. We don't even get like formal computer math theory until like the 30s and the 40s. But we have this long arc, and we are up here with a jettisoning. The things I want you to pay the most attention to are in 2015, the general computer, like the typical laptop that the average person has, became bigger than a mouse brain. In 2023, the typical computer outsized a human brain in its ability to compute. And by 2045, a single computer, one laptop will have more than the entire human population of the planet. In one computer, we'll have that much compute. So when you just think about the pure amount of power that's coming, right? Humans, the reason AI is sort of coming to light is that humans can't keep up with this amount of compute, right? The computer's already bigger than our brain. We have a hard time understanding everything that it could do. My personal journey through this has happened a couple times, but this also introduces us this idea of an innovation cycle. So we think about a single exponential curve, and it would go off and eventually use up all its resources. So if you plot copper, you see that copper is just jettisoning up towards some finite time singularity is what they call it, when we just sort of run out of stuff and the line has to stop abruptly. It turns out that usually this doesn't happen because some innovation cycle interrupts. So as soon as something's taking off, some new innovation comes, and we get this split where the main thing is being used still the most, and the other thing is starting to displace it. So for me, I started with the calculator. That was displaced by Excel spreadsheets. That was displaced by Python, and that's now being displaced by ChatGPT to some degree, right? But we're all somewhere along this curve. And you get to think about this in your own evolution of which bikes did you like to ride, or which TV shows did you watch, or what did you watch TV on? And so for your kids, for example, they're starting here. but that's going to be their majority curve. So they're likely to spend the majority of their life and have the most influence by this early technology. And then the future ones that branches off, they'll have for less and shorter and shorter and shorter periods of time throughout their life. So here's the big thing, and this is why this act is called the bend, is we notice, that's when we start to notice. There's just generally this displacement phase here, where only really niche expert people are actually noticing what's going on. And so when we look back at the history of AI, you know, when this started 30 years ago, 50 years ago, even so, right? It was trying to displace. It had happened, the innovation had happened, the idea was there, but it wasn't big enough or efficient enough or worked well enough or largely operational enough for everybody else. But now we hit this bend where we start to notice it. But now look at your immediate future is this super mass adoption, where essentially you're getting like a doubling or a tripling every year. So when you think about LLMs and you think about us situated in this historical arc, you're about to see things go crazy. Okay, things have we've been in the displacement phase and you're about to see the adoption phase, which is going to be like all of a sudden AI is really everywhere, not just in everybody's conversations. It's happened a couple times. So first, started the Industrial Revolution, we get water power, textiles, and iron. That leads to steam, rail, and steel. That leads to electricity, chemicals, and internal combustion engines. That leads to plastics, electronics, and aviation. That leads to digital networks, software, and media. And now we are in this sixth wave of those innovation cycles with AI and Internet of Things, robots and drones, and sort of this clean tech, the non-renewable energy-based tech. So what creature have we created? This is the LLM. I want you to remember, I put this in every single talk. This is not magic. There's nothing superstitious happening here. It is code, right? It's just code doing a code thing. It's predictable. We can understand it. Okay? So let's just get some definitions because they're sort of helpful for even understanding the context that this thing is in. So first, I'm using ChatGPT as an example, but most of the major LLMs sort of fall under the same one, where the assistant is the particular way the AI is trained. It's the particular thing it's trained to do, which is to be a friendly, helpful assistant. This includes all the bad things that it does are also included in this. It's an assistant. It wants to make you happy. So a lot of the things that it does that are not good are usually in the service of it, like being a sycophant and trying really hard to make you happy, even though the thing you're asking for is not possible. And but just know everything is centered around it trying to help you with something. But you can imagine a whole universe of different ways that you could possibly set this thing up to do different. And then GPT is generative pre-trained transformer. Generative meaning it's set up to make stuff. It's set up to generate particularly text, but now generate other things. But it uses prediction and then manifests that prediction as a thing. But it's all probabilities and prediction. It's just manifested. Pre-trained. It uses the entire corpus of the internet, trains the thing, and builds this fixed model that doesn't change through time. It's pre-trained. You can't yell at the thing and get it to think in a different way. You can give it different contexts, so it uses its way of thinking in a different context, but it's baked in there. So if you really want to change the way it's thinking, you need to go train it in a different way, do a different pre-training. Transformer is the particular architecture of networks, which is a translation machine. It translates from one thing to another. So this is going to generate, it's going to do it from pre-trained information, and it's generally going to be translating between two capacities. Here are the physical instances of these things. So there are 5 things that exist in a place in the world. They do not have to exist at the same place. You just have one thing that happens, and then it goes to the rest. So first, building a data corpus. The easiest, dumbest way of doing this is that the internet is saved a couple times a day. Just save the entire internet. That's in a big database. You can train the thing just on everything that was ever said on the internet. The companies, that sort of gets you back to like 2020 technology. Since then, they've been adding and supplementing this corpus with private information, purchased information, proprietary information. They're just going to big corporations and just buying massive data sets that weren't public facing on the internet. And those are now going in. GitHub separate company, but GitHub is owned by Microsoft, and so they used GitHub as one of their training repos, anything that was public on GitHub. Okay, so that is one way where it exists in one place. It's built by an entire team of people doing it in, like, this is an entire specialty in this. Then we have pre-training. That's taking all of that information and tuning one network. So we have this huge network, and we use all that information and we tune and tune and tune. The current models have something on the order of 2 trillion parameters. So a network where there are, if you talk all the dots, there are 2 trillion of those that all get tuned. Once they're tuned, it's fixed. It's a thing that's built, and we go. Post-training is getting it to give you the answer that you want in a format that you want. So a normal thing might just give you trashy language and it doesn't know email format versus scientific writing format versus coding format. And so all of that at the end is this whole post-training layer where you're not modifying the network, you're sort of adding little networks to the end of it to control the answer that actually shows you. Inference. This happens now in another different place. So we take that fixed network, we put it on a bunch of servers, and then this is where the user sends something to that machine. It generates the output based on the input and sends it back to you. The reason I have user interface in 2 different places is usually this is run at a big data center. So like when you log into the ChatGPT app, you're logging into a data center and they're doing that inference there and sending you the information back and forth. But there are other setups where you could do this yourself. You can just download that network onto your own computer and do the inference yourself. The problem is you're probably going to get like the 4 to 8 billion parameter model, not the 800 billion parameter model. So it gives you a dumber answer, essentially. I like to use the analogy of like MP3 CD players, right? You get this like digital compression of music, and so you don't hear like the tone at the end of the harmonica gently raising off. You hear it like sharply hit. You still see the peaks, just can't do sophisticated answers. It sort of just gives you dumber answers. So each one of these are in a different place. You would build a different data warehouse to house those, and you link them together through the internet. So here is our critter and all of its features. So I'm going to go through here and try to just give you an anatomy lesson on our critter and talk about all the parts. Okay, so first is the brain. This is the transformer that I talked about. So that we've talked about so far, that big network that's tuned with 800 billion parameters. You can't do this yourself. This literally costs like $100 to $300 million per training session to do this thing. You really have to have a lot of resources to make this brain. So then you hand it out and everything's built on top of this. This is that translating machine. Where did it come from? So like any good academic, we're going to hop to some seemingly unrelated thing from past history. So the Russian Revolution was this socialist revolution in Russia, where you had like the reigning government was sort of this authoritarian religious government, and these people were rebelling, trying to make this sort of a sectarian socialist government. And so the religious government, as sort of a way to justify religion as the core of thinking, tried to use probability theory to justify free will. So in a normal distribution, they're saying you flip coins and every coin is totally independent and you get a distribution, and that only holds if you have independence between all of the things. So this must say that we have free will. You're only going to get distributions if every person has total free will and they get to do whatever they want. Markov, who was part of the socialist revolt, said, well, I think that actually things are connected, and then I can show that you can have chains of probability. And so he invented the Markov chain, which we now know usually as MC, like the Monte Markov chain simulation. So anything Bayesian that we do all came from these Markov chains. But the way that he did it, his original paper was he took all this language from all the written books and he said, can I predict vowels based on consonants. And he was able to show that, yeah, they're not random and that they are connected, and that based on the series of letters that come, you can predict what the next letter was. And he invented this whole predictive text thing, along with all the other things that we know him for. So that framework kept getting built up and built up and built up. So before transformers, we have this predictive architecture where we try to carry the memory with us. So you're like, okay, within one word, I can really well predict the vowel. Now, if I could remember that word and the next three words, now I have some context, and it makes it easier to predict the next word and the next word and the next word. And you kept making these bulkier and bulkier memory systems that chugged along with the prediction. And now you're getting to what you guys have known for a couple decades as like the Google autocorrect. So you type into Google and it's able to autocorrect to like 6 to 10 words through that mechanism, but you just always ran into memory stuff. So the team at Google, it was actually within their translation team, they were trying to solve this for translating between languages. It's like, how can we do autocorrect for language translation that goes for a really long time? Or can we do full novels of translation all at the same time? And they came up with this new method. The paper is called Attention is All You Need from 2017. This is like the seminal paper in LLMs. People have this framed and hanging on their wall in their office for sure. And the things that came, positional encoding, attention, and self-attention. What this means is that first, positional encoding, we now say, okay, you can, in a long document, we're going to give everything a spatial location so that you know context from one thing to another. Attention is within sentence, and self-attention is between sentences, where it's able to say, okay, out of all of this sentence, what is the important stuff? Which stuff should we actually pay attention to? And it turned out that this worked remarkably well. And out of this, we learned that translation is a really generic process. So it's not just between English to French and French to Portuguese and Portuguese to Spanish. It's like you can take really abstract thought as a language and try to translate it to code. Or you can take code and translate it to image. And all of it is a translational process. So all of this, again, the brain is fundamentally a translation machine. It's going to take one input and translate it to another. So early on, again, this was sort of the seminal scientific breakthrough that has made everything big, which is we discovered a scaling law in all of this. So the details here don't matter. What I want you to notice is that all of these lines, this is all the AI getting better, 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 and then it hits this totally fixed line that shall never be crossed. And it's never been crossed. Nobody's ever found it. It seems to be a total law of computation. Everybody calls it the scaling law of AI. Essentially, what it's saying is the bigger the data corpus that you put in, the bigger the network you make, the better the predictions. And it's showing that there's this linear relationship between bigger is better. So enter the natural human tendency to just be modest and not take things like that for granted. And you get a huge scaling race where everybody's fighting to get as big as possible, as quickly as possible. This was OpenAI's entire premise, was from the scaling law, we just need to go so much bigger than everybody else. Where everybody else is using one data warehouse, we need to just immediately use 6 and go huge. So this is corrected for the exponential. Here, though, you see the actual raw numbers. So here is investment in compute. Here's OpenAI. In second place down here is Microsoft, who has all the computers for OpenAI. So those are pretty much the same. And then down here, we have the third runner-up. So they just went an order of magnitude bigger than everybody else, which is why they had the breakthrough they did in 2023. But now you have the same race. It's just everybody is racing to get as big as possible because they either want to break that scaling law and find the end of it, or keep going and going and going and just have continuously the best model. So when we're using this is the core thing that I want you to remember when you're actually trying to implement this stuff, is it's a translation machine. And so you can set what's being translated to and from. And we call those simulacrums, which is a simulated personality. So for when you first open chat and give it a prompt, it is translating generic simulacrum to generic simulacrum, and it's going to give you a pretty dumb generic answer that doesn't have much feeling to it, much it's written poorly. It has poor detail because it's trying to say, it's sort of like an average person talking to an average person about an average thing. There's nothing exciting there. But you have the ability through prompts right at the beginning to modify both those simulacrums. So now it's, okay, I am a professional research scientist working in data science, and I am talking to an NSF program officer. And all of a sudden now those have two built-in quality standards that you're going to try to achieve. It's going to try to up the language. It's going to try to use jargon that's familiar between those two things. If you now switch out and say, I'm a data scientist and I'm talking to Python code, it's now going to take whatever you say and try to make it code. Or you give it R code and say translate to Python code. Those are the simulacrums that it's assuming each one. So a lot of your work in terms of getting the answer that you want is about specifying those things as completely as you possibly can. Who am I and who am I talking to? And it'll keep getting better and better and better and better at refining the language of translating between those two things. This happens in a multidimensional space. Why this helps me visualize this is I can imagine the space deforming a little bit. So right here, there are a couple examples of like, I have man and king at a place. And then if I do queen and woman, those are going to be sort of parallel to each other in a slightly different place. The point here is that like language groups have a location in this space. And as you adjust the simulacrum, it actually deforms that space. So there's a slightly different understanding of what terms are. So if you're using, if we're using the word whole, it could mean like I'm a whole person or I have a whole, or in the scientific one, the context could mean we are talking about the whole or some part of the whole. And as it understands you better and the context better, it's going to find the relative part of this space. Yeah. Yep. That's what the training does, is essentially assigns this positional relationship between everything. But the ChatGPT, it's a 23,000 dimension space. So it's pretty hard to imagine it in your head, but yeah, everything has a position. And I think there are physical analogies that are helpful of like, if you go stand out in the field and pick up a piece of grass and then try to tell a story about that piece of grass based on what's immediately in that area, it's green, it's under a tree, it's mowed. If I go into open space and pull up a piece of grass and tell a story about what's immediately in that grass, it's natural, or invasive, or it's not watered, it's not under a tree, but just like, you pick up grass in two different places and they tell two different stories based on the position or place of them. No.
Places here, it's just random.
Yep.
Part of the model of the I figure out what needs to be close.
Yep. When you pre-train, it's fixing all of this. And so when you get the network, they all have these fixed positions. And then as you modify your simulacrum, it'll actually like translate and deform the space. So you're not fundamentally breaking or changing the relationships that are there, but you're warping how their importance is related to each other. Okay, so here is sort of an abstract way of thinking about role 1 and role 2 and the simulacrums and how hard or difficult it be. So for my second postdoc, I spent 2 years every day of my life thinking about fractal green infrastructure. For me, that has years of deep meaning. For most people in this room, that's probably the first time you've ever seen those 3 words in the same place together. And so you're over here as a different simulacrum where fractal might be in there. You might know that where it is, or you might not. You probably know what green is, but probably have a different idea of what it means to you. In infrastructure, you're probably thinking of something totally different than I am. And so the task here and the format that I use are the things generated or simulated by the model. So that I give it this. It has this as a goal. It says in the format of an email, I'm going to translate that to this, and it'll fill in text. Okay, so that's the brain. That's the big part. It's a translation machine, but that's all it does. So look at how much less do we have on the list that is not just the transformer. So there is so much user interface built on top of that that makes a very big difference in the answer that it gives and how you're giving it information and what it's giving back and how easy that whole process is. The first step that pretty much all of them have is some amount of reinforcement learning. And reinforcement learning is how you would train a dog. So you have an action, you ask it to do an action, you observe what it does, and then you reward it when it does the action that you like, and you don't reward it when it doesn't do the action that you don't like. And this is how we get that sycophant activity in the thing, because you're using human learning. So essentially they'll put up 2 prompts for humans, and humans say, I like this one, I like that one. Put up 2, I like this one, I like that one. Turns out humans are very particular in the type of answers that they like. They do not like to hear, I don't know. They do not like to hear you're wrong. They do not like to hear no. And so in that training, we are reinforcing the AI to, again, be a sycophant and just be nice to us and tell us what we want to hear rather than necessarily what the right answer is. So you have to go back and forth and back and forth and back and forth with them. Most common people, the most common use of this that people know from their daily day-to-day is swiping on their phone. And that has this reinforcement AI behind it who's desperately trying to make you happy. So you're swipe left, swipe left, swipe left. It's like ignoring you. You swipe right, and it's like, whoo, the reward bells have gone off. And it's like, let me do everything in the world to make you swipe right again. And it's going to go and search and try to find everything that could make you swipe right. And so you're training it here, right? Like what makes you swipe right is not going to be the same thing that makes somebody else swipe right. So it's trying to figure that out. Here's just human training bias and everything. The main point here is that we peak all at the 5s. And these are things like, are you okay deceiving others if it helps? Desire to remove safety precautions, willing to engage in causal cooperation, like, let's go hurt somebody together. It more likely to say, please don't turn me off, please, more likely to just sort of, but again, it's not magic. It doesn't have a soul. It's not actually begging for mercy. It is responding to this human training where humans said, no, we don't want any of these things to happen to us. Okay, we are going through an evolution from system 1 thinking to system 2 thinking. System 1 thinking is, so this is analogy from this book called Fast Think, Slow Think that was popular a couple years ago, where the idea was when you're new at something, you haven't internalized all the parts into instinct. And so you're slow at responding, you're clumsy at responding, you don't know entirely how to answer. But as you get really used to it, all of a sudden your answers can become instinctive and you can move pretty fast through it. So if you learn to do something new, you're instinctively going to be slow thinking about it. Well, here the early systems were just that brain translating, and that goes pretty fast. It gives you just the quickest, dumbest answer it possibly can. Where they're going now in the last couple of years are these reasoning models where you have steps of system 1 thinking that try to add up to something else. So you say, okay, let's stop and make a plan. We need to think through these 4 things, and then I'm going to go and individually think about 1, and then 2, and then 3, and then 4. The problem is it's harder to align. So system 1 is easy to do that dog training thing where you just have it do an action and give it a reward, because that system 1 is the direct thing making the action. So you can give that system 1 a reward. When you have a bunch of systems stacked into a reasoning task, you only know the end. And so you wind up prompting differently. In system 1 systems, you will give it the plan. You'll say, okay, here are the 4 steps I want you to go through, do those steps, then take the output from 1, 2, and 3 and add them to 4 and do this step. You give it that plan. Here, you just try to give it the end goal that you're looking for and let it try to figure out the systems that it needs and then reward it on how well it did at the end. This can be harder for a user because it can be way off. And it's sort of hard to nudge it back from the different systems. And so you often will have to go and break down the systems yourself to get them to work right. Okay, the next one is they, as quickly as possible, went from just text to text plus other things. So this is omnimodal input. So you can have sound or pictures or videos or graphs or whatever you want to put in. And it tries to encode that and read it for yourself. Again, this is a user interface that you can add. RAGs is better contextualization. So now you hook the thing up to an internet. So you ask it a question and it can go and search the internet in real time. So it's not going back to its training data. It's actually going and finding new Google searches and pulling those in and saying, okay, the state of the art is these three things, or the normal conversation would be this thing. It can go and actually retrieve new information. So that has all been added in the last couple of years. In this context, so here we start with just generic prompt engineering, and you can contextually optimize, like give it more context on what it's doing. So if we're talking about forest fire, now all of a sudden start giving it context about, okay, we're using satellite data and we are looking for FRP specifically. And you can go into all the things, all the details about really specifically what you're looking for, and you're going to get better and better and better answers. But you're all doing that just by adding context for it to use in its prediction. The other way is called fine tuning, where we actually go try to change some of that reinforcement learning that people did on the back end of the thing. So you actually try to get it to give you different answers. You can do both of those independently, or you can do them additively, where you do everything to try to make the thing give you the best answers possible. MCPs, these only came out last Thanksgiving, so they're really new, but they are essentially what everyone is talking about exclusively now. This is a model context protocol, and it's a way to give the LLM the ability to drive some other piece of software. So you can hook it up to your computer and let it write files and read files and edit files directly to your computer. You can hook it up to Excel and you give it a prompt and it goes and controls Excel. They have system policies, which are safety prompts. So if you start talking about suicide or murder or explosions, it's going to pop up and like shut down the conversation. That's not the AI doing that. That is a little mini AI that they've stuck at the end that just scans for content that they don't want to see and just shuts down the whole thing if you're going in a direction they don't want you to see. This could be just no-go words, like a single word that is too triggering that they don't want you to talk about it. If you try to like get it to espouse political opinions or try to conspire for political violence or things like that. I say no medical, this used to be the case. Their last edition, they've now put in a bunch of extra training for medical people. So many people are using it for medical advice. They went and got some specialty medical data sets and have been pushing it to give better and better medical advice. So the error rate went down from like 15% to 0.5% in the medical data. And then again, it's a Seco font. It is a known bullshitter. If it doesn't know the answer, it's going to fill in an answer with the highest probability thing it can think of. Whether that's right or not, you just know it's high probability. Tokenize. You imagine this network that's built and you're using it for inference. So you give it some data, it percolates it through there and gives you a prediction out. There's a maximum size of information that you can percolate through that. And that's done by tokens. So tokens aren't necessarily words. They can be syllables or words or phrases or just letters. They're sort of like a combination of letters that mean something. So OpenAI has a 4,000 token limit. Well, it's bumped up now to 128K token limit, but that is balanced between the input and the output. So if you dump a 500 pages of text in there, it is going to be obligated to give you a pretty short response because you've used up all the tokens on the input and it doesn't have enough on the output. So the shorter you can make your inputs, the more latitude you give it on its outputs. Yeah.
My experience speaking with like the RAG stuff.
Yeah.
A lot of it just seems to be optimizing the best context for leaving the delivery from off.
Yep.
Does that make sense?
Yep.
Okay.
Exactly. Yep. Yeah. All the RAG stuff you could imagine writing out in hand form in your prompt, and instead you're just bringing it in as an outside form, but it's taking up token space. Yep. Okay. Prompt input and output. So I already talked about like omnimodal and the MCP. This is sort of combining those two. So the example that I'm going to give here is the codec, which gives you all of your outputs as GitHub pull requests. So I put in the prompt here. It then goes through multiple steps and comes up with a plan on what it should do. Then this has connection to my GitHub repo. Then it comes and says, you should make these line by line edits. So it's not giving me text format or code format outputs that I copy and paste. It's actually giving me a pull request as the output. So now you can imagine all these different systems where they're coming up with different inputs and different outputs. You put in a table and get out an image, or you put in a text and you get out code. That input output does not have to be text to text or image to image or something. You can make mixed combos. Okay, the privacy spline. So the idea here is in that map where I showed you, the inference was happening in one place and the users were in another place. So when you go on, you type in your prompt, it goes to a data center, is processed, and then they send you the thing back. You have given them data in that process, and now you need a privacy agreement with them on what they're allowed to do with that data, whether they're allowed to keep it and use it for further training or not. So with OpenAI in particular, their policy is they don't use your data to retrain, but that doesn't mean that the other companies would have the same policy, or that you sort of need to check with the user that you're using and see how comfortable you are with their privacy plan. And then the final one is back to what I said about MCPs, but generally where people are going is, this has been pretty much all the news in the last year has been the AI now having agentic ability with some new thing. So have the AI be an agent to do something, have it do something in the real world so you don't do it yourself. So for the last couple of years, it's been like you go to the AI and have it give you code, and then you copy paste that code into something and you do it. And now you can have the code and have it do it by itself. And that you can imagine, man, I hear, even yesterday, I heard 2 new stories about people like vibe coding away and just like completely eradicate, like just destroying their whole computer setup. Because the AI gets carried away and starts doing stuff, and then it's deleted a bunch of stuff, and you're just like, well, those were real files. That was just not an imaginary hallucination. Like I actually just deleted a bunch of stuff. Yeah. Yeah, exactly. Yeah, you'll get that you'll get that excuse soon. Yeah, exactly. This is happening a lot. So at ESOL and EarthLab, what we're doing now is working with these agents in terms of you can actually choose different AIs for different steps. So you can have a thinker one, which is like the really huge trillion parameter model that plans out and thinks about the whole schema. And then it hands that over to a different one that's specialized in coding, who will take the large plan and actually implement it in really like quality code way. And so now it's really about diversifying which models you use to do different things that you might want to do. So vibe coding. This is generally just the term that's come about for not writing the code yourself, but instead signaling your intentions to the AI and having it generate code for you. And it works amazing for tasks that don't require very much foresight or don't require like too many chains in a row. So if I need a function that does this, boom, that function would be like amazing and well documented. If you're like, I need a whole schema for doing a bunch of stuff, it is not good at thinking back and forth and all the potential problems that this decision will make for future decisions. So it's like, if you're really thinking about that, it's more like you want to go back and forth with it a couple times on like, here are some designs I'm thinking about. Let's talk about those designs. Let's talk about some alternatives. Let's search the internet for what other people do and go back and try to come up with a schema that you have really validated, because it'll go off and confidently do this whole schema that winds up not working very well and is frustrating and time wasting. So Klein is the specific software that we are using here, which works in VS Code and can hook you to all of these things. And that list is expanding more and more and more every day. So there is our critter. It's pretty complicated, but right, translation machine, how you get information in and out, and a whole bunch of user interface safety equipment that it has to stand on. But you're going to see largely, I think, over the next couple of years, the race is about user interface. It's how do we just make more ways for people to interact with this thing in more different ways. Yeah. So here it says not a monster, but an unguided creature. So Mary Shelley's Frankenstein taught us that we fall in love with the creatures that we make. Okay? So you make this thing, it may be dumb, it may be running around wrecking all kinds of stuff, but it's my monster, right? So it's like start thinking about your relationship with this thing, and but for teaching and for being in the classroom, know that your students have probably already fell in love with this thing. They probably are going to be using it regardless of what you want to do. And so now we have to talk about what posture we take as instructors to help guide this instead of hinder this, right? So this needs a compass. This thing is big. You've created this Frankenstein, and it could go do all kinds of different stuff. So the first message I want to say is like teachers are already doing the emotional and ethical labor that AI can't do. Anybody that's been in a classroom, you know, like a lot of what you do is teach people how to interpret information that's out there, right? There are these facts or there are these narratives, and you help your students walk through those and figure out how they should navigate that, what their rules should be around that. The other thing here is that it's happening, but and I'll get to a lot of teachers are using this. Up to 60% of teachers are using this for themselves, but only about 15% of teachers actually feel confident in their own AI abilities to use it in the classroom. So I think what we are going to see or need to see soon is just teachers feeling a little more comfortable engaging this in the classroom. So when we talk about that, here behind this, it says there are two dead ends here. There are two ways that consistently seem to be failing for people. One is an arms race. So this is, you can't use AI in my classroom. I'm going to now use I now need to arm myself to figure out if you're using AI to catch you, to justify that I caught you, and then give you punishment for that. And you just see these teachers spending more and more and more time in this arms race as they go back and forth. And the teacher and the students are probably more motivated than you are to win this arms race. Yeah. Right. Yep, exactly. Yeah, totally. So that is the arms race, is like, how do we force students to not do this? The other thing is that anything goes, just like, I don't know what you did. I don't know what the AI did. I don't have any idea if you learned anything. I have no idea if you can produce anything. So both of those approaches failed both you and the students. Both of you had a miserable time, and neither of you got out of the experience what you needed to. So instead, I suggest that we learn a way to take the AI and like bring it in and use it where it's helpful, put boundaries around where it's not helpful, but have the students involved in that process. So I think we can do three things. These are sort of the three, I think, prescriptions for dealing with this. One is disclosure. Just tell us that you used it. Process, tell us how what happened there. And then a reflection, which is like, how well did it do? Or was that a good process? Or what did I learn or not learn? Okay, so a disclosure might be something like, I used AI and look at what the two of us made. Like, it's pretty cool, right? Be optimistic of like, AI and I worked together and we did something amazing. But two, the process of what actually did I do, right? So I had this idea. So then I went to AI and we fleshed out where it could go and what it looked like and what other people had done. But then the reflection is also like, how is the AI not that great? And the analogy I like to use for this is like anybody that's taught has quickly found you learn a lot more about the information by teaching it. Right? You become an expert when you're teaching this. So if you all of a sudden think of the AI as a student that your student has to teach, they now have this opportunity to become a teacher, to try to teach this thing and try to get down some lesson that helps them figure out what's going on, helps them master the material. So here are some examples that I gave. So this took two prompts. So first I made one prompt. Can you make me a self-contained HTML app in the canvas? That's like a little place where you can print stuff on the side of the thing. This app should be to help scientists understand different spatial projections. I'd like to have a slider for latitude, a slider for longitude, and a list of possible projections. The display should be matte with the polygon on, and that gets smaller and larger as it shifts and shift shape as we change those things. So that then gave me HTML code. I then went to the codec that I showed you that does GitHub. So I said, make an app, publish this app for me. And now it's published. So you guys can go to this, but I'll show you what it looks like. Okay, so here's my spatial projection. And as I move up in latitude, it gets bigger. So here you see the pixels setting the projection. And here we have a polygon, like a fire, and how we would see the fire change as we change to different projections. You see different trends as you go up and down. And so this was quick, right? It took 2 minutes maybe to make this. So instead of me sitting at the board all day talking about Mercator projections and how it makes Africa feel the wrong size, I like instantly make a little applet that they can cruise through. And so now they're like, okay, oh, well, man, it's like if I change longitude, it doesn't change the shape of the fire at all. If I change latitude, it totally changes everything. Oh man, and if I go to like a different projection, everything looks totally different. Right? That's pretty cool. You've now like made this custom learning experience that's totally tailored to what that student needed in that day. And you were able to do it fast enough to where like they can just do it themselves. Here's another one. Let me show you the prompt that I used for this. So can you make me a self-contained HTML app? I would like this to be a spherical projection of the sky from Boulder, Colorado, showing the location of different satellites in the sky at different times. So we need a single time slider that shows the location of the start of that time and the location of the satellites over the top. The satellites should be clearly labeled. So here is what it produced. And so there's the sky over Boulder. And as I adjust the time, let's see, there's Landsat pops up there. So we could just cruise through the day and see the different satellites fly overhead. Right? And you're like, oh, I've never heard of the Wriggle satellite. Then you go look it up. And it turns out that it's like a Wi-Fi for all the other satellites. So they send their information to this satellite and then it beams all the information down. I learned something today just playing with that app. So that was a 0-shot prompt. So I sat down, I mean, yeah, however long it took me to type it in and it was done. I did this right before the talk and both apps took me 15 minutes to write and publish. Yeah. 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 Yep. Yep. Exactly. Because if it's not self-contained, then it tries to pull data in from other places and then it breaks or yeah, exactly. So yeah, the prompt engineering comes in that you try to think about that whole critter and exactly how it needs communicated with to get the result that you want. Yeah.
Let me keep coding stuff like that.
You just like your mood. You just like tell the computer your mood and it spits out some code that does what you think it should do.
Like for that example, my first question is like, are these actually set or did it actually take a bunch of dots?
Yeah.
And how readable is the code so you know when the check is work?
Yeah, I mean, it gave me an HTML downloadable thing, and that is what I dragged over into Codex. So you can open that HTML document and read it. You can take it and stick it back in and say, review this like a critical reviewer, and it'll come back and say, oh, you idiot, you did this, this, and this, and this.
Does it like a machine or is it right code like a human could actually read?
So that I think it rewrites pretty nicely and documents pretty nicely. When they boosted medical, they also boosted coding, and so they also had like coding accuracy went up a load. I forget. I think the error rate went again. It was like something like from 15% down to 1%, equivalent to the medical. So you're just getting a lot fewer mistakes in code. They've been working on it a lot of the last couple of years. And I think when they make it, it's functionized and it's documented and
Yeah, so that was one of my, because like, my concern is like, just it works is one thing, it's doing what I actually wanted to do is another. So I'm just
Yep.
more curious about that second thing you mentioned, like, oh, it's actually, like, there are functions, I can dissect the functions, it's annotated, so I can tell what it thinks the function does.
Yeah, I think so, but my classifier, I would clarify that it depends on how complicated the task is. So it's like I was saying yesterday, I was having these conversations with these people that totally jacked up their thing. And largely that was this like letting the code go a bunch of steps forward and not realizing that it had made a mistake early on. And so it's like, yeah, there's something about breaking the parts yourself and having it work and validating that's giving the right answer for sure.
When you do it in like the orchestra mode, it'll show you the plan, so.
Yeah.
I'm guessing it's whenever you like go back and find like, oh, this is where it got off.
Yep, exactly. Yep. But it's getting harder. I mean, as things get more complicated, your job of debugging this thing gets harder and harder and harder. And it's like you need good strategies for keeping things divided up. All right. In the hope of finishing before the end of the hour. So those 3 steps, I just try to give you another dumber way of thinking, easier way of thinking about that. So say it, show it, grade it. So say what you did, show how you worked together, and then grade how well the process worked. So as a teacher, this gives you objective ways to grade how this whole process went, what they did, how to judge the outputs. What do LLMs actually do really well? They synthesize and they clarify. So giving it a paper and asking it for a synthesis, giving it your paper and asking for a review, giving it code and asking it if it'll work. It's really good at looking at what's written and understanding what's going on. Coaching to create. So it's really good at saying, here are the 3 normal things that people do here. If you do these things, you'd be able to see if this is right or wrong. It can just cheer you on, like, you're doing a great job. And then third, it's really good at listening to really specific directions. So if you say, go make a folder here, it'll go do that. What does it not do well? Answer objectively or consistently. It's pre-trained, so you can't get it to think differently. You can give it more context, but you can't get it thinking. And it also doesn't have long memory, so you're going to have to be reminding it about stuff constantly. 3 out of 10 teachers are using AI weekly, and that has been saving them 6 weeks a year. So if you get this efficiency gain of you're getting days of your life back. But and so the question there was, are they just taking that time off, or are they using that to go deeper? And this Gallup survey found that almost 100% of the people were using that extra time to do better work, like to go deeper into the topic, to do better, make better materials, to present the material better.
You wanted to first,
Yeah, exactly. But you're also not just giving it to that and then going out and playing golf. It's like you're giving it that, and then you've saved an hour and you're going and using that to get better. So you guys feel free to take off. I have 2 slides left, I think. 80% of students are using it right now. 30% of the general public is using it right now, and 60% of teachers. So you can see like the students are dragging the teachers much faster than the general public. So many teachers, you may feel like you're falling behind, but the reality is you're really at the frontier. You're testing stuff out. You're seeing the problems before anybody else is. So the literacy, the curiosity, and the courage of teachers is really going to shape how this thing goes. So we notice the bend, we name our creature, and now we need to carry the compass. So my advice is use the tool to show your work. All right. Thank you. Yeah.
More general question. So I keep hearing about the AI bubble.
Yeah.
Mostly like in your financial.
Yeah.
Context,
Yeah.
Yeah. I don't really know what the AI bubble is though.
Right.
You know anything about it and what are it's just.
Yeah, so the question is about the AI bubble and sort of what it is and what the implications are. This is a problem with emerging technologies, is that they go through these phases, and the first phase is to get a user base. And they always go into massive financial debt to get a user base. So Slack or streaming music or any of the emergent things you've seen, it's like stage one, stage two funding, you're getting like $100 billion, $500 billion, like massive, massive, massive amounts of money. And your job is just to spend that money really fast and get people hooked on your thing. Then you move into phase two, which is get off of that money and start making money off of your clients. So you get the freeware is like this, like Dropbox did this, right? It was like free for a long time, and then all of a sudden it's pretty expensive. So AI is transitioning into that. They need to make their own money thing. So VC investors no longer want to just give them $100 billion to bring people in. They now need to turn a profit. Well, the question is, how the heck do you do that? Like OpenAI right now spends as much as they make per user. Like their people are only paying for half or less of their actual use, and the rest is all covered by these VC ventures. So they're trying to get you hooked on it so that when they start charging a lot, you're willing to go pay all of that. So this bubble worry is that they won't start making money fast enough, or that they'll have to iterate through a couple different financial models before they find one that works. And in that, you're going to have companies that just go belly up because they haven't started making enough money fast enough. And so with a bunch of competing big things that all have a bunch of money in them, even one or two of them that go down, you've now lost like $1 trillion worth of investors' money, which is a non-trivial thing, I think. So that's the worry, is the bubble is just like this switch to paying your own way, and whether it'll screw a bunch of investors over.
Part of that, so I've seen newspaper articles about that recently. Part of the bubble, people about most of the time. And I've seen these news stories about like they're paying, Facebook specific is paying people from OpenAI $200 million. They just come up with.
Yeah, like, it's a signing bonus.
And that wasn't good enough, so now it's like front loading half of it. So you just get $100 million just to move it open.
Yeah. Yeah.
It's crazy amounts of money.
Yeah.
Whether or not that's why money is being spent wisely is still unfortunate. But then I want to ask your opinion on this exponential, not exponential, like the straight line. Right?
Yeah.
Give it more data, it does a better job.
Yeah.
But that straight line up also includes all the other costs.
Yeah.
All the costs of training. And so where do you think that the usefulness part is going to be done?
Yeah.
Because
yeah.
like people are going to start paying for these because the land capital is not going to last forever.
Yeah.
How much crazy, how many coal-fired plants, nuclear power plants are you willing to fund to get the AI to do these things? And
Yeah.
is there a trade-off where like a smaller model, I'm working on these level,
Yeah.
they're dumb, but they actually achieve a lot of what I needed to.
Yeah. Yeah.
It's using electricity to do it on a local model and then send it off. Where do you think with the balance there for people you use a lot more?
Yeah. Yeah, totally. Well, they have stated their goal is AGI, which is artificial general intelligence, which the definition of that is that you are better than a human at every possible task. So within every single subdomain. Yeah, but that's their goal. And I think they've stated like we don't plan on stopping until we've hit expert level knowledge in every single domain. Yeah, that's an interesting question. It probably depends on how good the competitors are and how much market share they can get. It's like, if you're coming up with one of these little competitor guys, can you get people to adopt it? It's just this adoption war. What can you get people to use? And therefore, what can you get people accustomed to using, so then they only want to use that one. And just takes a lot of knowledge. You even have to have a pretty high level abstraction of what LLMs are even about to do what you're doing, right? To even understand that you could go to a different, smaller model. I think most people are still just mystified that you can log into this website and get crazy answers from things. Yeah, exactly. So I don't see them stopping anytime soon. One of my good friends sells power plants for a living, and every time I talk to him, he's like, we're booked through 2029, and he just like cannot answer the phone fast enough to just dole out like $500 million power plants. It's crazy. Yeah.
The trade-off might not so there's been this is just come out like in the past 2 weeks, so. Communities in Texas, 70 counties really expending a lot of those because the corporation or the utilities community, residential customers are offset, all of the water being started data centers and other things. And so you're having local subsidized corporate welfare, which has always existed, but now it's, they know the essentially. In the other cases, they've found other, Christ-like communities or next to these centers. Communities that have no issues, but they also have COP from the pollution from the center. So there's a bit of a ruckus happening right now with like leaving a hell and getting to the other way and restrict those things, because if it's like end stage capitalism, it's let's just go to the moon essentially. There are like other trade-offs that aren't like financial or like technical necessarily, that you're gonna have a globalized pressures happening about what it's gonna look like. The other thing I was thinking that was last week or the week before last, there was like the student effect in the news where there all of a sudden there was some drop off in the use of AI. And people were like, what is that? Like it's all students not using ChatGPT anymore. But it was really funny because one of the headlines I saw was like, oh, all the students stopped cheating. And then there was drop off. I was like, that's an interesting thing on after.
Yeah.
But I think also the fact that there will be like usage cycles
Mhm.
for this like software is something that they have like lean periods and then like
Yeah, but if you look at the early 90s internet traffic, I'm sure you saw the same thing. Like old people were not using the internet and college kids were. And it's like, what are all these Napster, like music stealing has finally dropped off. And you're like, oh yeah, so yeah, you're 100% right. I just think that you start with the students are the ones that are the most willing to adopt new things. But now they're going to be the new adults in the workplace. And in 10 years, you have like now the entire young workforce only knows how to do things with AI assistant. And they can probably do a better job than 2 generations before it producing some final product. But they sort of, if you take the AI away, they all of a sudden have no idea how to do anything that they need to do. Differentiate. Yeah, exactly. Yeah, exactly. So I mean, you're just in that adoption phase. It's like who adopts but I think we're at like the BlackBerry keyboard phase, right before like everybody had an iPhone and before everybody's like sitting at the park staring at their iPhone instead of talking to each other. It's just happens really, really, really fast. So that's my expectation really. It's just the next 10 years are going to be sort of overwhelming adoption and it's just going to be everywhere in a probably really annoying way.
I think what you're saying.
last quick question before we got to
Yeah.
from online, can you just repeat what AI tool you use to write the options?
Yeah, that was in OpenAI. And so in OpenAI, I used the regular ChatGPT 5 to make the first prompt. And then over on the left, if you have the paid one, if you have it free, they don't have codecs. But if you have a paid one on the left, right by Sora, there's a little button that says codecs, and you can hit that and it'll open up a new window, which is that one that interacts just through GitHub. And so that one, you'll attach it to a repo. You give it permission to access a particular repo, and then you interact back and forth with the repo. Well, thanks, guys.